Okay, so this is section 9.1, and we're going to talk about conic sections. It's called conic sections because we are dealing with how the shapes we get when we cut a cone a certain couple different ways. And so we've already seen from the intro video that we're going to find distances. We're then going to look at circumference, area of a circle, and looking at a graph, knowing what shape is what. Okay, so in this image, we're going to see cones here, and we have all of our different types of shapes, and we'll talk about each one of these shapes in different sections, but right now it's just an introduction. And you'll see here in this first one, if we cut the cone parallel to the slant of the cones, it's only going to cross one of the cones and we're going to get a parabola. So we've talked about parabolas, but that's how we would create one. Now if we look at this other one and we draw a vertical line that goes right through the tip of the cone, so the height of the cone, and then we cross it, the one at the top here, we cross it perpendicular to this vertical line, we're going to get a circle. And because it's perpendicular to this vertical line, that gives us even distances around from each edge of the cone. And if you think in 3 dimensions, it'll be equidistance all the way around from the center of the cone. Now, if we slightly change the angle of the line that goes through the vertical one, it changes the radius. We can still kind of consider a radius, but it's not equal all around. So we'll have different lengths from the center going up and down and left and right. So it's not going to be equidistant. And then this last image, we have two different shapes. If I draw a vertical line directly through anywhere except the center of the cone, so not including this line, we'll get what's called a hyperbola. We basically get two parabolas that are going in opposite directions. We can also draw a angled line. As long as it crosses the cone in two spots, we'll still get a hyperbola, but notice one's going to be larger than the other. Whereas in this one, where it's a straight line up and down, the hyperbolas will be equal to each other and symmetrical. And so now these are important formulas that you're going to need. Distance we've already discussed. I'm going to go ahead and write this down still, but it is the square root of x sub 2 minus x sub 1 squared plus y sub 2 minus y sub 1 squared. Midpoint formula is the average of the x's, and it's a coordinate. It doesn't matter what order we put the x's or the y's in. I just list it this way. I kind of can keep it consistent with my distance formula, so I create a process for me to remember. Circumference is equal to 2 pi r, or it's equal to the diameter times pi. And then the area of a circle is equal to pi r squared. Those are important formulas. So that's all we're doing in this video, just a couple formulas, and then we're going to get into graphing and doing some examples.